Good day, gentlemen. I, Dr. Anand Pandey, along with Puneet Taluja and Pragyatip Manglik, present this paper on pollution control machine using artificial intelligence and machine learning. Abstract of this paper. What is this paper all about? In this project, we are using various technology which we'll use in the following manner. We have used um, air sucking machine with the help of exhaust fan filtration of polluted air before entering into the machine. Target the atmospheric air into the ionization process. Ionizing the atmospheric gases, capturing the carbon after the ionization process, utilizing the residual carbon to generate the electricity, using IoT to operate the machine from anywhere. Learning algorithms we have used to get efficient working of the machine. Details of the input. We have used in this obviously the polluted air, which is the input here in this machine. Obviously the output is the clean air, which is clean from carbon and other harmful components, gases, compounds, etc. Now come to the evaluation parameter. The evaluation parameters of our machine is based upon the amount of air we put into the machine, the amount of time taken by the machine to process, the amount of electricity generated out of the byproduct, and the total time of purified air after this process. In this introduction, we have given a picture of a metro station at New Delhi. Here you can see as if it is a black and white photograph with the Indian flag because of air pollution. Now, if we consider pollution, the general definition of pollution is the introduction of contaminants into the natural environment that causes adverse changes is called pollution. It can be of any type. It can be, say, air pollution, light pollution, littering, noise pollution, plastic pollution, soil pollution, radioactive pollution, thermal pollution, visual pollution, sorry, and water pollution. These are different kinds of pollution. But here in this project, we are considering only the air pollution in general. Now, the major pollutant need to be considered and sufficient cleaning technologies are chosen to be chosen. Particulate matter. To solve the problem of particulate matter, we use mechanical particulate filters and electrostatic precipitators. For gases, we have used solvent type of technology for now diseases. Study estimated 695,000 premature deaths in 2010 due to continued exposure to outdoor particulate matter and ozone pollution in India. By 2030, the expected growth in many of the sectors will result in the increase in pollution related health impacts for most cities. Now, innovative idea about this project. You see, um, this pollution around us is the major innovation and motivation behind the idea of our project. This is the basic diagram depicting the basic principle of our machine, which will be of a kind of container sucking the air from the atmosphere with the help of some rotor blades adjusted on the motor. Then there will be various filters. At last, there will be an electricity generation process which is not shown in the figure. The purpose of this project. As you know, the health effects of pollution are depicted in this figure. Various gases, like carbon monoxide, ozone, sulfur dioxide, nitrous oxides, are responsible for illness in our respiratory system. Nervous damages lead results in nervous damage, and which is responsible for headaches and other things. Then skin disease, cancer, etc. These are from air. Suspended particulates is an assembly of fabric filter bags, commonly called a bag house. A typical bag house comprises of an array of long, narrow bags, which each about 25 centimeter in diameter, that are suspended upside down in a large enclosure. Dust-laden air is blown upward through the bottom of the enclosure by the fans. Particulates are trapped inside the filter bags, while the clean air passes through the fabric and exists on top of the bag house. The fabric filter dust collector can remove very nearly 100% of the particle as small as 1 micron, and a sufficient fraction of particles as small as zero point zero 0.01 microns. Fabric filters, however, offer relatively high resistance to airflow, which leads to the substantial energy usage of the fan. So, as you can see in the baghouse filter, the energy consumption is very high. Some energy is consumed in cooling the coils, some energy is consumed in running the high, very big, this thing called fans and other things. So, in the present system, as you can see in this picture, this is bag house enclosure, bag house filter is shown in this figure. As you can see, it is control of the gases. Control of the gases. Gaseous criteria pollutants as well as the volatile organic compounds and other gaseous air toxics are controlled by the means of three basic principles: absorption, adsorption, and incineration, which is called combustion. These techniques are employed singly or in combination also. They are effective against the major greenhouse gases as well. In addition, fourth technique known as carbon sequestration is under development. Absorption. In absorption, what we do, we have a liquid which is used as a solvent for the pollutant, and then comes wet scrubbers and packed scrubbers. Wet scrubbers, similar to those described above, for controlling suspended particulates, may be used for gas absorption. Gas absorption can also be carried out in a packed scrubbers or towers, in which liquid is present on the wet surface rather than as droplets suspended in the air. Hardware and software requirements. As far as software is concerned, for AI and machine learning related activities, we need MATLAB. And in terms of hardware, we need um, cuprous aluminum chloride. Then other salts are also needed, like charcoal, activated charcoal, sodium hydroxide, magnesium oxide, lime. These are the things that we need hardware and software. Rest of the components that we used, microcontroller, Ethernet shield, etc., etc. This table depicts everything. Software analysis and design. To reduce air pollution, we have done an experiment to purify the air from the harmful particles. To purify poisonous air, electroprecipitator can be adopted to remove dust, ultrafine particulate matter, smoke, smog, and microbiological contamination like bacteria and viruses from air through the electrical forces. Apart from this, a 12 feet high machine is equipped with a lot of hardware devices, and those devices are working on a combination of different technologies under the single concept of artificial intelligence. Learning algorithms that we used. We have been using some of the self-learning algorithms so that our machine later learns itself for various actions that we want it to perform and work accordingly based on previous tasks and past experiences. Although we will be feeding it with algorithms, but soon it will be able to work on its own and will serve the use of official to keep continuous check on it. Hence, it will be able to process on its own. So we have used here supervised learning and reinforce. Now, electrostatic precipitation. As per the studies which we have conducted till now, we have been able to gather the list of various harmful pollutants, namely oxides of carbon, hydrocarbons, acids, and particulate matter. So this is how electric process is done. Method of implementation. So basically, we are more concerned about carbon here because carbon is creating more problem as compared to other particulate matter. This is the real picture of the machine that we are working on. We have put our machine on open area and then created pollution by using two sources. Since it was completely an open area, it was difficult to calculate the pollution generated. But as far as we are able to calculate the approximate result by the following assumptions. The pollution sources were kept in open area but specifically creating most of the pollution in area around 4 cubic meters. Now, according to the mole concept in open area, 1 cubic meter of air weighs 1.225 kg. So 4 meter cube of air would weigh around 5 kg. Therefore, we are having around 4 to 5 kg polluted air, and as far as our motors are concerned, we are able to predict as around 70 cubic meter air is taken by fan in a minute. So out of 5 kg, 1.5 kg polluted air is sent for filtration. Now when we looked at the filters, then suspended when we looked at the filters, then suspended particles and the particulate matters plus the carbon which got deposited on the HEPA filter. Then after the electrostatic precipitation filtration, we were able to receive around 500 grams per second for of filtered air and around 20 grams of carbon elements. There are six AQI categories, namely good, satisfactory, moderately polluted, poor, very poor, and severe. The proposed AQI will consider eight pollutants: PM10, PM 2.5, NO2, SO2, CO, ozone, NH3, and PB, for which short-term national ambient air quality standards are prescribed. Thank you for being part of this project.